All right. So at this point, so we should be able to explain the concept of positive and negative logic in terms of voltage level. So let's talk about positive. Let me first describe positive and negative. Positive logic. So I'm gonna write positive logic versus negative logic. All right. So in positive logic, so logic 1, the number with the highest positive number, highest positive, I'm going to represent highest positive as H plus. Highest positive number will have logic 1, will have a 1. So which means the other number will be a 0, because in binary, remember here in binary we only have 2 numbers. So if we are dealing with the positive logic and the highest positive number is a 1, which means the next number, because here we're talking about voltage level, and when you talk about voltage levels, they're always going to give you 2 different voltage level. It's either a highest voltage or lowest voltage. So in positive logic, if the highest, in positive logic, automatically the highest positive number is going to have a 1, which means the other number is going to have 0. So we're going to give an example, don't worry. And then in the negative logic, we are more interested in the highest negative number. I really don't know what to call this number. I'm referring to a number which is negatively high, like far from 0. That's what I'm referring to. So let's call it a highest negative number. When I give an example, you guys will probably understand what I mean. So this number here in the negative logic is going to represent a 1, which means any number that is positive or highly positive is going to represent a 0. Why? Because we are dealing with the negative logic. I hope I'm making sense. Here we just explained normal logic level, voltage level, where a highest voltage represents a 1 and lowest voltage represents a 0, without specifying either we are dealing with the positive logic or negative logic. But now we are dealing with the concept. So here, in this here, we just explained voltage levels as interpreted by digital circuit, without specifying whether it's a positive logic or a negative logic. Now here, it's very more important to know because sometimes the examiner might be specific. Let me take an example. The examiner say we have 2 different voltage level, 0 volt and 5 volt plus 5 volt. All of them are in the positive logic. So if all of them are in a positive logic, let me not write positive the whole thing, let me just write plus logic. All right, to save more space, plus logic. So all of them are in a positive logic. So which means if 0 volt and plus 5 volt are in positive logic, in the concept of positive logic, 0 represent what? 0 volt is going to represent a 0, that's automatic, and plus 5 volt is going to represent a 1. Now it makes sense. So let's go to another example. I'm going to take another example. That was example 1. Let me take example 2. Examiner says that the examiner gives us 2 voltage level, one which is minus 5 volts and the other one is plus 5 volts. But this is what the examiner tells us. The examiner tells us that these 2 voltage level are operating in a negative logic. So what is your take in this? Minus 5 volt represent what? Remember, we are dealing, this is a negative logic concept we are working on. So minus Minus 5 volt is going to represent a 1. And plus 5 volt is going to represent a 0. Why? Because we are operating in negative logic concept. Remember here, in the negative logic, we are more dealing with the highest negative number. Let me take another example. Example 3. If examiner give us 2 voltage level of 0 volt and minus 5 volt, 0 volt and minus 5 volt, and examiner says, and these two are operating in negative logic. Negative logic. So a 0 volt is going to represent what? A 0 volt still represents a 0, and a negative volt is going to represent a 1. That's it. Negative volt to represent a 1. So I really believe you guys understand this. Let me take another example. Examiner gives us 2 examples. Let me take the same example, but now in a positive logic. 0 volt and minus 5 volts. So these are the 2 voltage levels. And examiner says that these 2 voltage levels are operating in a positive logic. So 0 volt represent what? What will 0 volt represent? 0 volt is going to represent a 1. Why? Do you see the difference between example 3 and example 4? In example 3, we are operating, we have two voltage levels, 0 volt and minus 5 volt, and we are operating in a negative volt. So in a negative volt, our interest is more light in the highest negative voltage that gets a 1. So 0 volt represents a 0 and minus 5 volt represents a 1. But in the same example now, 0 volt and negative 5 volt operating in a positive logic concept. So 0 volt is going to represent a 1. Why? Because in this concept, 0 is more positive than negative 5. Negative 5 volt is going to represent a 0. That's it. So this is this for the positive and negative logic.